In the series of the kinetic theory and gaseous state, today I like to try to explain one important mathematical function which is very essentially required for the formulation of Maxwell distribution of molecular speeds, and that mathematical function is called the gamma function. And this we shall not go for elaborate discussions of this gamma function, but we limit ourselves to that point which is required for the formulation of this distribution law. And this gamma is a limited definition of the function of the gamma function, gamma n. Gamma n is equal to 0 to infinity and t to the power n minus 1 and e to the power minus t and dt, in which this n is greater than 0, means n is taken positive, and the variable t changes from 0 to infinity. So this is the mathematical definition, unlimited mathematical definitions of this gamma function. Gamma n equal to 0 to infinity, and here t is the function and t to the power, here if n is the quantity, then here it will be n minus 1 and it will be minus t and dt. And from this formula we can get the reduction, formula. Say gamma n equal to 0 to infinity and t to the power n minus 1 and e to the power minus t and dt, and it is the integration of the product of two variables. Whenever we do this type of integration product of two variables, then first term will be the first variable and the integration of the second minus the differentiation of the first and integration of this second. So it will be this t to the power n minus 1. This is the first part of this variable, and the integration of the second minus 1 and e to the power minus t and limit 0 to infinity, and minus integration 0 to infinity and minus integration 0 to infinity and differentiation of this first, then n minus 1 into t to the power n minus 2 and integration of this second minus 1 and t to the power n and e to the power minus t and dt. So this is the integration of the product of two variables. This is the first variable, this is the second variable. First variable remains in first in the first term, first variable remains intact, the integration of this second, and then minus integration having the same limit, and here the integration differentiation of this first one and the integration of this second. So if we put here this limit minus if we omit this minus, then t to the power n minus 1 and e to the power minus t, and this limit will upside down, means infinity and 0, since we have omitted this minus sign, and this minus plus, then it becomes plus, and here n minus 1 will go outside of this integration, and 0 to infinity, and here t to the power n minus 1, n minus 2, and e to the power minus t and dt. If we put this limit here, then t equal to 0 power something, anything will be equal to 0, and this was 1, 0 into 1 equal to 0. So it will be 0 minus, whenever we put this infinity, then t, it is the exponential term, t, whenever we are putting this t equal to infinity, this will very rapidly rapidly reach to 0 value. So 0 into something, again 0, and this term in the format of this gamma function, we can write plus n minus 1 and gamma here n minus 1, here n minus 2, so this gamma n minus 1 e to the power minus c dt. So the reduction formula, becomes like that. This gamma n equal to n minus 1 and gamma n minus 1. Here I have written this gamma n equal to n minus 1. If we do the repeated or successive integration, then this will give you the n minus 1, and when n minus 2 and gamma n minus 2, and this is equal to n minus 1 into n minus 2 into n minus 3 and gamma n minus 3, and so on. And this way it could be, in this way it could be extended. So now we may consider some cases. We may consider some cases, very important cases. Here it is written, in this case n is positive. So now we consider the two cases, especially the case 1, when n is positive integer. Whenever n becomes a positive integer, what will be the reduction formula? Then gamma n we can write n minus 1 gamma n minus 1 and this is equal to n minus 1 into n minus 2 into gamma n minus 2 and so on. This equal to n minus 1 and n minus 2 into n minus 3 in this way by repeatedly reducing the gamma function. Then it becomes 3 into 2 into gamma 1. Gamma. We cannot find out. Suppose gamma 5 equal to 4 into 3 into 2 into 1 into gamma 1. So unless and until we can evaluate this value of gamma 1, we cannot find either gamma 5 or gamma 8. Now we may come to this evaluation of this gamma 1. Evaluation of gamma 1. So whenever according to this formula, according to this format of this gamma function, this gamma 1 equal to 0 to infinity and t to the power then n equal to 1 minus 1 and e to the power minus t into dt. This is equal to 0 to infinity, t to the power 0 equal to 1 and e to the power minus t and dt. If we do this integration, then minus e to the power minus t and integration and limit is 0 to infinity equal to e to the power minus t and minus is eliminated. So here the infinity to 0 and this is equal to wherever 0 limit is placed instead of t it is 1 and whenever infinity is placed it is by minus infinity equal to 0. So this is equal to 1. So we have got the value of gamma 1 equal to 1. Value of gamma 1 equal to 1. Now it is very easy. Say gamma 5 equal to 4 into gamma 4 equal to 4 into 3 into gamma 3 and this one equal to 3 into 4 into 3 into 2 into gamma 2 and 4 into 3 into 2 into 1 into gamma 1 and we have got this gamma 1 value equal to 1. So this will be equal to 4 into 3 into 2 into 1 and this you can write this 4 factorial. 4 factorial. So gamma 5 equal to 4 factorial. Here also in this way, if we see the gamma n equal to n minus 1 into n minus 2 into n minus 3 in this way 3 into 2 into gamma 1 equal to 1. So it is equal to n minus 1 and factorial. So gamma n equal to n minus 1 factorial. So automatically by this way we can write this gamma 3 equal to 2 factorial or gamma 2 equal to 1 factorial equal to 1. and gamma 3 equal to 2 factorial equal to 2. Gamma 4 equal to 3 factorial equal to 6, and gamma 5 equal to 4 factorial equal to 4 into 3 into 2 means 24 and so on. Again, if from this formula gamma 1 equal to 1, we can have one very important formulation, factorial value of this factorial 0. Factorial 0. When it is 1, then gamma 2, when 2, gamma 3, when factorial 3 equal to gamma 4. So when 0 factorial, we can write this gamma 1. 0 factorial, whenever 2 plus 0, instead of 2 we can write 0, then 3 equal to 1 and gamma 1 equal to 1. So this is a very important concept, you can say, the important concept, the gamma factorial 0 equal to 1. Only by the use of this gamma function we can evaluate the factorial 0. Now the case number 2. Case number 2. When n is half of odd positive integer. Such that 3 by 7 by 2, 5 by 2, 3 by 2, half, etc. In this case, what will be the expressions of this gamma n and reduction formula? So here this gamma n equal to n minus 1 into n minus 2 into n minus 3, and it will be 3 by 2 into half into gamma half. So if we like to consider this gamma 5 by 2, then it will be 3 by 2 into half into gamma half. So again we are facing one difficulty. If we could not find this gamma 5 by 2 unless and until we can get the value of gamma half. So gamma half could be determined by this fashion, gamma half. Evaluation of gamma half. So now let us come to this gamma half. What will be the value of gamma half? So for this evaluation, let us consider the integral. Let us consider the integral I equal to 0 to infinity and e to the power minus x square dx. Yes, this is I. Let us let us consider this integral, and now we like to evaluate this value of I. So this I square equal to 0 to infinity e to the power minus x square dx into 0 to infinity e to the power minus x square dx. This we can write 0 to infinity e to the power minus x square into dx, and 0 to infinity e to the power minus y square dy. Since both these limits have the same limit, so irrespective of the nature of the variables, the magnitude of this one and this one will be the same. So this one we can write 0 to infinity, and x and y both are the variables, 0 to infinity, and here e to the power minus x square plus y square into dx dy. This integration could easily be solved if we convert this Cartesian coordinate into polar coordinates. And x and y, these are the independent two axes perpendicular to each other, and as you see, the suppose here 0 and x and here infinity, and y, and here also plus infinity, means the x and y, this is origin. X and y both are the independent, and these two are perpendicular to each other, and both are having the limit 0 to plus infinity, 0 to minus infinity, means we are considering the first quadrant. This is the first quadrant. First quadrant. And whenever we are considering the first coordinate, suppose this is the point P, and this one is the arc having the limit 0 to infinity, and this is phi. And phi is having the limit 0 to pi by 2. 0 to pi by 2. Whenever this radial distance coincides with this x-axis, it is 0. When it coincides with the y-axis, it is pi by 2. So this one you can write 0 to infinity, and e to the power minus r square, and you know, I have already discussed in my last video lectures that dx and dy equal to r dr and d phi. So dx and dy equal to r dr d phi. So we can write here r dr and 0 to, here limit 0 to pi by 2 and d phi. This is equal to, you can easily show this integration is equal to half. This integration equal to half, and this integration is pi by 2 equal to pi by 4. So I square equal to pi by 4. We can show this integration equal to half. Let us see this integration. Let us see this integration. 0 to infinity, and e to the power minus r square r dr. Let r square equal to x. R square equal to x. So r twice r dr equal to dx. So this integration we can write, limit will remain the same. Whenever r equal to infinity, x is also equal equal to infinity, r equal to 0, x equal to 0. So this is 0 to infinity e to the power minus x d x and half. r dr equal to half dx half here. So if we limit, then half into minus e to the power minus x and 0 to infinity, it will give you half, and minus, if you eliminate e to the power minus x and infinity to 0, and this one equal to half. Infinity, whenever you are placing for x, it is equal to 0, so this is half. So naturally, this integration I square equal to pi by 4, or I equal to half root over of pi. So this integration have the value, this integration have the value half root over pi. Now we like to formulate this integration, this in terms of this gamma format. This integration, so half root over of pi equal to this integration, and this integration equal to 0 to infinity e to the power minus x square dx equal to, and now let x square equal to t, or twice x dx equal to dt. So 2 into x equal to root over of t, and dx equal to dt, or dx equal to half e to the power minus half and now putting here again, limit will remain unchanged, 0 to infinity, and here half, and t to the power minus half into e to the power minus t and dt, half t to the power minus half into dt. This you can write this half, and here 0 to infinity, and t to the power half minus 1, then also the minus half e to the power minus t dt. So according to this format definition of this gamma function, this one you can write this half, and gamma you can write this gamma half. So half and half you can cancel, so we are getting the value of this gamma half equal to root over of pi. So gamma half equal to root over of pi. This has already been evaluated. Now this gamma n, whenever n is a half of odd positive integer, then it will be n minus 1 into n minus 2 into n minus 3 into 3 by 2 into half into gamma half. Instead of write gamma half, we can write root over 5. So this gamma 5 by 2 equal to 3 by 2 into half, and gamma half, and this is equal to 3 by 4 and root over 1. So in this way we can evaluate the values of gamma 7 by 2, gamma 3 by 2, gamma 9 by 2 and so on. Case number 3. Case 3, when n is positive quantity, but other than integer or half of or positive integer or integer, the integration is not so easy, and we shall not go further to describe details of this case number 3. We shall limit with this case number 1 and 2, when n is positive integer and or n is when half of odd integer. This gamma function has a lot of application to find or to evaluate the standard integrals, which are not so easy to do by successive integrations. Say application, it can be written as application of the gamma function. Number 1, let us consider the integration 0 to infinity x to the power n and e to the power minus x, e to the power minus, suppose ax and dx. If we like to find out this integration, it is not so easy to do it by successive repeated integrations. So here first the n is a positive integer. So if we do this integration, then this integration we shall have to arrange, we have to transform into the gamma format. And for this changing into the gamma format, e to the power minus e will be always there. So let ax equal to t. Ax equal to t. So a into dx equal to dt and dx equal to 1 by a into dt, and again x equal to t by a. So if we substitute here, then it will be 0 to infinity. Instead of x, we are writing t by a to the power n, and instead of this one it will be minus t, and instead of dx we can write 1 by a into d. So this will be 1 by a to the power n or 1 by n. So it will be 1 by a to the power n plus 1 and integration 0 to infinity, and here t to the power n, e to the power minus t and dt. So this will be equal to 1 by a to the power n plus 1, and this one will be into gamma n plus 1. N plus 1. Whenever gamma n plus 1, this t to the power n, one digit will be reduced. So this integration becomes very easier. Say this integration now becomes gamma equal to gamma n plus 1 and a to the power n plus 1. So as we know, the gamma n plus 1 equal to n factorial. So n factorial, so we can write this integration 0 to infinity and x to the power n into e to the power minus ax dx equal to n factorial and divided by a to the power n plus 1 or gamma n plus 1 divided by a to the power n plus 1. So if we do this integration 0 to infinity and x equal to 0 into e to the power minus t, then this will give you e to the power ax into dx equal to, then it is 0, n equal to 0, so it will be the gamma factorial 1 divided by a factorial gamma by a. Or similarly, if we do 0 to infinity, a 1 into x into e to the power minus ax dx equal to, and here n equal to 1 means gamma 2 and a 2 equal to 1 by a square. So in this way, say suppose 0 to infinity x to the power 3 and e to the power minus ax dx, this will give you the factorial or gamma 3 plus 1 divided by a to the power 3 plus 1. And gamma 3 plus 1 means factorial 3 and this will be factorial of 4. Gamma x to the power n is 1 3, n equal to 3 to the power minus x dx equal to, this will be the formula, means factorial 3 divided by a to the power 4. Now we are considering another case, another applications which is a little bit complicated. Integration number 2. These are called the standard integrals. These standard integrals is equal to 0 to infinity, where x to the power n and e to the power minus bx square into dx. Such type of integrations we frequently meet while getting these derivations of this Maxwell's distribution of molecular speeds. So here also to be changed in gamma format and bx square equal to suppose t and x equal to 1 by 1 by x equal to t by b and root over. X equal to t by b root over. So here twice b dx equal to dt, or 2 instead 2x dx, 2bx dx equal to dt. So twice b into, instead of x we can write t by b into dx equal to dt, or dx equal to half, or you can write here also twice into root over bt into dx equal to dt. B here, b square and b will cancel, so bt. So dx equal to half and 1 by root over of bt into dt. So here, instead of writing this value, this becomes 0 to infinity. Limit will remain unchanged when x equal to infinity, t equal to infinity, x equal to 0, t equal to 0. So here, instead of x, we can write t by b and n by 2. n by 2 and e to the power minus t, and instead of dx we can write half into t to the power minus half, and here b to the power half into dt. t to the power minus half, and then here b to the power half. So this will give you the 1 by b to the power 1 by 2 and b to the power n by 2 plus half, n by 2 plus half, integration 0 to infinity, and here t to the power n by 2 and minus half into e to the power minus t and t. Let me check it. 1 by 2 and here b n by 2, here b half. So b to the power n by 2 plus half, 0 to infinity, e to the power and t to the power n by 2 minus half, and e to the power minus t and t. So this you can write 1 by 2 root over b n plus 1, and 0 to infinity. This one you can write this t to the power n by 2 and plus half and minus 1. Then also coming this power e to the power minus t and t. So this will give you the value 1 by 2 and root over of b n plus 1, and when you are writing this in terms of this gamma function, then gamma n by 2 and plus a half. So the integration of this, the value of this integration now becomes very simple, and say this one equal to 1 by 2 b to the power n plus 1 by 2 and gamma n plus 1 by 2, n plus 1 by 2. simple. I have also written gamma n plus 1 by 2 and 2b to the power n plus 1 by 2. You can set some examples. Say say 0 to infinity x to the power 0 and e to the power minus bx square into dx equal to, here n equal to 0. So n equal to 0 means that gamma half and divided by here 2b half, and this is root over pi. Gamma half equal to root over pi. Gamma half root over pi. So this will be equal to 2 into root over b. You can write the half and root over pi by b. When one case and second case, so suppose 0 to infinity a to the power 1. E to the power minus bx square and dx equal to, here n equal to 1. 1 plus 1, 2 by 2, that means factorial gamma 1 and twice b and gamma 1. So it will be simply 1 by 2b, 2. And 3, 0 to infinity x square to the power minus bx square into dx equal to, then n equal to 2 means gamma 3 and divided by gamma 3 by 2 and e to the power and 2 b to the power 3 by 2. And 3 by 2 means half, and gamma half equal to root over pi, and here 2b 3 by 2. So we can write 1 by 4 and pi by b. So instead and putting several values x square, x cube, e to the power minus bx square, dx and so on, we can get the we can find a chart for the odd integers and even integers. This one the integration I. This is the result. So we can write a chart here, n equal to even and n equal to odd integer and even integer. And n equal to 0. 0 is also even integer. So in this case I will be equal to half root over pi by b. n equal to 2. I equal to n equal to 2. I equal to 1 by 4th root over of pi by b cube. n equal to 2, n equal to 3. I equal to 3 by 8 root over pi by b5. n equal to 5, n equal to this one n equal to 4, n equal to 6, even integers. Then I equal to 15 by 6 and root over pi by b to the power 7. Similarly, when n is odd integer, suppose n equal to 1 and I is equal to 1 by 2t. When n equal to 3 and I equal to n equal to 3 means 1 by 2 b square. When n equal to 5, I equal to 1 by b cube. And when n equal to 7, I equal to 3 by b to the power 4. So these applications are very much useful whenever we shall discuss the Maxwell's distribution of molecular speeds. This is all about in a brief discussions on this gamma function. In my next class, I will go in a very short way the concept of probability and the concept of distribution of a certain property among the molecules. So this will be discussed in. These are all forming the basis of this Maxwell's distribution of molecular speeds. So thank you all who are watching my video, and if you like, then please subscribe to encourage me to do more video lectures. Thank you all again.